Lesson 2.5. Today's fun to hear. I get to teach basic derivative rules. Now, this is, okay, where you don't have to rely on definition of limit, the definition of derivative name. Okay, we're going to know the shortcuts. Now, she kind of breaks it down into very basic small pieces. And so some of these pieces at the beginning are going to be very much basic. They build onto each other. Okay, and I will say there's memorization involved. There's just flat out some things you just have to memorize. Which you guys understand that, you know that. But just beware, okay? So, first thing we're talking about is derivative of a constant function. When I talk about a derivative of a constant function, where it's y equals or f of x equals just a constant value, yes? So, derivative of a constant function. Well, the derivative of a constant function is always going to be the same thing. It's always going to be 0. And here's your reason. What's the line y equals 4 look like? Or excuse me, negative 4. Or y equals 45 looks like? Or y equals 0 look like? What's that line look like? Jacob's doing this, right? It is a horizontal line, right? And so, if I call this f of x equals c, what is the slope of a horizontal line? 0, every time. So, the derivative of a constant number, or just a plain old number, is always 0. Okay? So, if y is negative 4, if that's the function, what is y prime? 0. If s of t equals 45, what is s prime of t? 0. If f of x equals 0, what is f prime of x? 0. Okay? If k pi over 2, if y equals k pi over 2, what is y prime? 0. Because realize, 2 is a number, yes. Pi is a number. And k, when they put things like k and c in there, they represent constants. X's and y's are your variable. Things like c's and k's are constants, which means they are numbers. So k pi over 2 is all one big constant. Okay, so that's your first rule.
If it says cosine,
Cosine is not a constant. That'll be tomorrow. That's like page 3. Cosine and sine are just, all the trig functions are just ones you just need to flat out memorize. So, okay, single variable rule. And this is all going to culminate when we get down to power rule, which power rule kind of takes derivative of a constant, single variable all together. So, the derivative of x is 1. So here, what does the equation y equals x look like? Y equals x at that line there, right? And what is the slope of that line? Right? That slope is 1. So what is the derivative of just a plain variable? 1. So, right there, the derivative of x equals 1. So if f of x equals x, what's f prime of x? 1. If s of t equals t, what's s prime of t? 1. If x of t equals t, what's x prime of t? 1. Okay. Basics.
I like those.
Those are easy. And as I said, right now it may seem like, oh, I'm going to have to keep those straight. However, they'll kind of become more natural here. Okay, this is the big one. This is the easiest one, the one we probably use the most. I love this one, okay? Power rule. Okay, it reads funky. Give it a moment. If n is a rational number, then the function x to the power of n is differentiable, and the derivative of x to the n is n times x to the n minus 1. Okay? As I said, I know it reads funky, right? But this is the power rule. And basically what it's saying is if you have x to the n as your function, to take the derivative, we multiply by the power out front, and you decrease the power itself by 1. Okay? That's all we have to do. So if it was x to the n, we'll move the power out front, and then in the exponent, we'll decrease the power by 1. We'll use this rule for any type of variable with a power. Okay? So if y equals x squared, then y prime. We move the power out front, which is what? 2. It's still going to be x. And then what do we do with that power of 2? Decrease by 1. So I wrote 2 minus 1 for the moment. So y prime is going to be what? 2x. Okay? If f of x is x to the 4th, move the power where? To the front. And do what with the power in the exponent? Subtract 1. So 4 minus 1. And so when we clean that up, that is 4x to the 3rd. Am I always going to be writing that minus 1 in there? No way. Okay. And maybe some of you guys are already angry with me. Okay, C. We're using the power rule. This is a square root. What do you know? Okay, yep. Before you start thinking what's the derivative, we will never have a rule for taking the derivative of a square root or any root, because a square root or any root can always be turned into a power, an exponent. So that will always be your first step then. So if y equals x to the 1/2, okay, y prime. Take 1/2 out front times x to the, okay, here come the fractions of the day. 1/2 minus 1. Well, that was not too bad. Negative 1/2. So y prime 1/2 x to the negative 1/2.
Can I just leave it like that?
Nope.
Are you sure?
Mostly. Okay, so her question, as you guys all heard, was can we just leave it like that? Most of the time, I'm not saying you're going to have to rationalize, but don't leave a negative exponent. Okay, that's how I feel like AP works more, is they don't necessarily rationalize, but they also don't necessarily leave negative exponents. So if I write this without a negative exponent, how are we going to write this? Not 1 over 1/2.
1/2 over 1 over negative.
How about 1 over 2x to the 1/2? I'm actually going to change that to a square root here in a moment. Not that you have to, but we'll talk about that. So the 1/2, 1 stays on top, 2 stays on bottom. The x to the negative 1/2 needs to go to the bottom to become positive. And so you could write it as 1 over 2x to 1/2, or you could write it as 1 over 2 square root of x. Okay? Most of the time we don't necessarily worry about rationalizing unless we need to, but negative exponents we kind of stay away from. I am perfectly fine with either of those. Okay? Okay, D. Do we have a derivative rule for fractions yet? Nope. But 1 over x can be rewritten as x to the negative 1, correct? So when you do your derivative, negative 1 out front, yes. X to the What's -1 minus 1? -2, yes. Are we going to leave it as -1x to -2? No, we're going to say what? -1 over x squared. Okay, 1 over x squared. Well, do we have a derivative rule for a fraction? No, but 1 over x squared is x to the -2. So, f prime of x, what you got? -2 x to the -3, which is going to be written as -2 over x to the third. Okay, last one. What do we know about 1 over x to the 2/3? I don't want to think cube roots. I just want to know that it's x to the -2/3, yes? Okay, let's see how we do with our fractions here. Out front is -2/3, x to the, now we're doing -2/3 minus 1. What is 1 in this instance? 3/3. So this is going to be -2/3 x to the -5/3. And hopefully you guys are fitting yours in the box. Mine's fine in my paper. As I write this, -2 over 3x to the 5/3. Okay. Tomorrow, we're going to kind of broaden that into the general power rule. But you notice every time, basically, to do a basic derivative with powers, you're decreasing the power by 1, yes? So if up here you had x, t, and t, decreasing the power 1 means the x is gone and we're just left with the coefficient. Up here, decreasing the power 1, well, you can't because there is no power to begin with. So, okay, we will work on this tomorrow. I don't know if you know enough to make it worth starting on homework or not. Probably not, because they really mix them up with other pieces, and we don't know all the other pieces yet. Otherwise, I'd say start on homework, but I'm not sure it's worthy.